Welcome to my video on matrix definition and spectral matrices. This is going to be the first video in my series on matrix math. And so what we're going to look at here is just the basic definition of a matrix. A matrix is a rectangular array of numbers. It could be functions as enclosed in a bracket. The numbers or functions are called elements or entries. Very simple definition, but we're going to see it's going to have very powerful implications in the world of math and physics and science and engineering and economics and medicine and you name it. They're everywhere. So they're a good thing to learn about. So let's just write down one, just your simple generic matrix right here. 2, 1/4, and -3 and 18. So that it's going to have 6 elements in it, and there's going to be 2 rows and 3 columns. 3 vertical columns and 2 horizontal rows. Now, if we want to write a little different matrix, we can make a whole bunch of these. 6, 9, 2, 1, 0.3, 1/2, 8, 4, 2. Okay, now this one is going to be a 3 by 3 matrix. 3 rows, 1, 2, 3, 3 columns, 1, 2, 3. And it's also going to be called a square matrix because the rows and columns are equal. So they're, in theory, they look pretty simple, and once you learn how to do them, they are very useful. So now let's look at kind of the in general, what we have like in general. And we're going to have a matrix. We can represent it by a bold A if we want. A of j, k, and that is going to be little indices. So those are A sub j sub k. It's not a multiplication. Those are the indexing numbers of A. So if we want to write that out, A11, A12, go to A1 of n. So that's the first entry, row and column, row and column. And so this is going to be an M by N matrix. So that's going to be the rows. That's going to be the columns. So in this case, we've got N columns. So the second row is going to be A1, A21, A22, all the way down to A2N. And then we can just continue this down to A sub M1, A sub M2, all the way over to AMN, where M is going to be our row, so that's the mth row. And here we've got MN, M row, N column. So that's where we write that. So M is equal to the number of rows, and N is equal to the number of columns. So if M is equal to N, we have a square matrix. And if M does not equal to N, we have a rectangular matrix. So that's kind of our general notation. Now we can represent vectors by matrices. We've talked about vectors before. I've got several videos on that if you want to watch them. You can look them up, and it goes through all the different definitions of vectors and how they work. But we're going to let a vector A, small letter, A sub j, it just has one index, since it's either by a 1 by m or a 1 by n matrix. So we have a row vector, and A is equal to A1, A2, all the way down to A sub n. And then we could also just write an example of that. Just plug some numbers in there, -5, 2, 4, and 9. So that's going to be M by N. So M, we've got 1 row, and we've got 4 columns. So that's a 1 by 4. Now if we make a column vector, and as you might guess, that's going to be in the form of a column. So A now, we'll call this B, just to keep them separate. B1, B2, all the way down to B sub M, because we have M rows. An example of that would be B is equal to 6, 9, 24. Or any numbers you want to plug in there, or equations, or variables. So they're very powerful. So m by n is equal to 3 by 1. So that would be the way we would represent vectors in the form of matrices. Now let's look at what does it mean if two matrices are equal. If two matrices, A is equal to, and then there's the matrix A of JK and B of B and JK are equal, then A is equal to B if and only if they have the same size and each entry is the same. So there's two criteria, same entries, same size. So let's look at just a matrix here. This is a square matrix with 4 elements, a 2 by 2. Now let's see, this is going to be equal to, it's just itself, 1, 2, 3, 4. So that is equal, okay? Those two matrices are equal. Now, if we want to write column vector, 1, 2, 3, 4, is that going to be equal to this row vector, 1, 2, 3, 4? The elements are the same, 1, 2, 3, 4, but the sizes are different. One is a column vector, one's a row vector, so they do not equal each other. So it's a very simple definition. Everything's got to be the same. That's really what you need to remember for equality. Next, we will look at multiplication of a matrix by a scalar. The product of any m by n matrix, A of AJK, and any scalar, so C is just a number. It's not a, it could be a function actually. It's just going to be a number or a scalar, written as CA, it's just the product, is a m by n matrix, and we're going to just carry the C through into each element. So the C carries through and multiplies by each element. So it is obtained by multiplying each element of A by C. Let's do a simple example. So if A is equal to 1/2, 4, 8, 0, 1, and 5. Now let's take 4, so that's our C, 4 times our matrix now. So it's 4 times 1/2, 4 times 4, 4 times 8, 4 times 0, 4 times 1, 4 times 5. We're doing each element one by one. 4 times 1/2 is just 2, 4 times 4 is 16, 4 times 8 is 32, and 4 times 0 is 0, 4 times 1 is 4, and 4 times 5 is 20. So this is going to be our matrix if we take this original matrix and we multiply it by 4. So it's pretty straightforward, but it's need to understand that. All right, well, I hope you got something out of this video about matrices, and it's just an introduction to them. We're going to be more videos to explain more parts, more definitions, and more examples, and just what matrices are and how they work. If you like this video, give me a thumbs up, subscribe to my channel, and I want to thank you for watching.